The kinetic energy proof is a little bit more complicated, but remember, you don't have to memorize the proofs. Hopefully you can read them after the fact and they kind of make sense. Really the key is that you can work with those end equations. For kinetic energy, we're going to start the same way. The work done, in this case to accelerate something, is the same as the energy gained. We know that work done is always F times D times the cosine of the angle, and that's going to be equal to what we eventually call kinetic energy. What's cool about this one is if we're pushing or accelerating something, we can use Newton's second law and replace the F with ma. We are going to assume that we're pushing it in the same direction that it moves, so we're going to go with an angle of 0 degrees. So our energy equation without too much work becomes ma instead of the F multiplied by D multiplied by the cosine of 0 degrees. Cosine of 0 is exactly 1, so our energy equation becomes E equals MAD. That equation isn't wrong, it's just we can simplify it a little bit more. So we're going to go a little bit deeper, we're going to use some kinematics. Let's suppose that we push it from a speed of 0, from not moving, and we push it so hard or so long that it ends up going at some arbitrary speed v. What I'd like to do is get rid of the a and the d in this equation. So let's think about an equation that involves v1, v2, a, and d. It's the difference of squares equation. D equals v2 squared minus v1 squared all over 2a. If we put in that v1 is 0, that means this whole thing is gone. And instead of writing it as v2, we can just write it as v. We get d equals v squared over 2a. There's different ways to go here. Some algebra, some different ways to substitute it. I'm going to do maybe a weird step. If I multiply the a over, then I get a times d equals v squared over 2. It's not often we substitute two letters, but this a times d that I've got is exactly what's in this energy equation back here. So if I make that substitution, a little bit more room, I have that energy was equal to MAD, and we just figured out from kinematics that AD is V squared over 2. If we substitute that, then energy becomes mv squared over 2. That's how we write it. That's what the equation is, but more commonly we clean it up. I'm going to put a little k here to stand for kinetic. I'm going to pull the 1/2 to the front, and then mv squared. Kinetic energy is 1/2 mv squared. Since there's a v squared term, as your speed gets bigger, the energy increases quite dramatically.